Okay, so we were looking at Kirchhoff's rules. Now, usually we can analyze circuits a number of different ways. Usually students will latch on to one way or the other. We'll see which one works best for you. So we talked about this first one. That's like our current rule. What does the rule say for this? Mhm. That's our junction rule. Let's see, how can we put this together? Let's see, we'll do.
Oh, you're getting close. We're almost there. Oh, we're all finishing.
Okay.
She had to add in that buff.
So now we have another circuit. So let's see. So there's the delta V of the first capacitor. There's the delta V of the second capacitor. Okay, so the second one, the loop rule, well, let's go in order. So all of your delta V's all the way around the circuit they all have to sum to zero. So these are your two rules. So then you're going to need some sign conventions. Okay, so The first thing you're going to have to do is pick a direction to travel around your circuit. It doesn't matter which way you choose. It's just going to change the sign on your delta V's. So it's like you could say around this one, I'm going to travel that way. So in the direction of the current. You could. What? There isn't a correct way. Because it depends on the way you're traveling. It'll be negative or positive. Just try to follow what I'm doing. That question didn't really mean anything. Okay. So if you cross a resistor in the direction of the current, your delta V is negative IR. So point A, point B. There's your resistor. If your current's going that way, you're going to travel from A to B. If you're going in the direction of the current, you get a negative sign. On a capacitor, if you travel from plus Q to minus Q, you get a negative delta V. You remember how those are set up? So your capacitors are going to line up with the terminal of the battery they're connected to. So if I cross that capacitor going plus to minus, I get a negative delta V. Crossing a resistor going against the current, going the opposite direction of the current, you get a positive IR. So it's this again, except this time, I is going that way, you go from A to B. You get a positive IR. So again, traveling from if you're going around the circuit and you cross a capacitor going from the negative Q to the positive Q, you get a positive delta V. Not necessarily. Look at the capacitor. Your positive, look at the diagram. Your positive and negative plates, your positive Q and minus Q, line up with the terminal of the battery that the capacitor is attached to. And all it is you're either going from positive to negative or negative to positive. On these two capacitors with that pathway, you're going positive to negative both times. Both of those will be a negative delta V. Also, your two resistors there. In that particular circuit, you cross both of those resistors going in the direction of the current, so you get a negative IR. If you cross a source of EMF from negative to positive, your change in electric potential is your positive EMF. So if you're going from A to B, this one will give you positive EMF. So if you look here, if I travel around that circuit that way, that will give me a positive EMF because I crossed the battery going negative to positive. And then if you cross the battery going the other way, it's a negative EMF. So I'm going to show you a circuit where you're going to solve a system that has series and parallel combined, and you don't even have to know how to do the series and parallel just yet. So what we're going to do is, okay, so across the top, and have a resistor there. Then this is going to split. We'll get a resistor on the top, resistor on the bottom. Okay. And then we're going to have our battery down at the bottom. Go like this. Now, your resistors, 4 ohms, 5 ohms, 9 ohms, and then your EMF is 6 volts. Now, which way is your current going to run? Yeah, so your current's going to run like this. We're going to call that I1, because in here at the junction, it's going to split that way. I2 is going to go up and across the top. I3 is going to go down and across the bottom. Are you? You use it quite a bit in the human body. A lot of your, especially your electrical instruments, are based off resistance. So as you get to the other side of that loop on the top, I2 and I3 recombine to reform I1. Okay, now I have 2 loops. Again, it does not matter which direction you go. Here's how I chose to do it. I'm going to go, whoops. Yeah, same thing. I'm going to go that way on both my loops. So I'm going to make a clockwise motion around the system. It is. I wouldn't really suggest it. You're gonna start getting positives and negatives all over the place. So let's start thinking about, so here's the thing. We want to know the currents, I1, I2, I3. So here's the way Kirchhoff's rules shape up. I have three things I do not know. It means I'm going to have to generate what? Three what? Three equations. I'm going to need three equations to solve for the three unknowns. What is my first one? That's my first one. Now I can do each one of these loops individually. So I'm going to do the delta V's for the bottom loop. So that's going to give us the delta V of the battery plus the delta V of the 4.0 ohm. Now, here's how you handle a loop where you have these resistors split into parallel. You're going to continue across your clockwise motion around the lower loop. You can choose to use either one of those. You're going to have to choose to cross one of those resistors in the upper loop. You can choose which one. I chose the 9 ohm because it's still at least down inside the lower loop. So then what I'm going to need is also the delta V of the 9 ohm resistor. And these all sum to 0. That's a 9. That's a 4. So I crossed the delta V of the 4, and then I chose the 9. Okay. Because you just imagine to complete your loop, it's like I'm going like this all the way around. And then I just said, well, then I'm going to go this way and then back up and out and all the way around and so on and so forth. Yeah, for the lower loop, yes. I could have chose to go up across the 5 as well. I just like the 9 because it's at least down inside the lower loop. Now for my top loop. So here's my second equation. Top loop. So this is just going to be the delta V of the 5.0 resistor plus the delta V of the 9.0 resistor. So let's start. So the I1 equals I2 plus I3. That's pretty straightforward. We can do that. Let's start putting our positives and negatives in here for the bottom loop and the top loop. Okay, so your bottom loop, that is going to, so your delta V for your battery, as you notice the way I'm going, I cross the battery negative to positive. That's positive EMF. I cross the 4.0 ohm resistor in the direction of the current, negative I, resistance to the 4.0. And now look at the 9.0. I crossed it in the direction of, I crossed it going in the direction of I3. No. Well, I mean, so if you look at the way I3 goes, I crossed the 9.0 going in the same direction as I3. Negative. And let's go ahead and put in the currents in here. So this will be I1. Because you're looking at the direction of the lower loop. I'm going clockwise around that. You see, I3 splits off and goes that way, across the 9 ohm resistor. I'm going in that same direction when I cross this. For the lower loop that I'm traveling. So since I'm going in the same direction as I3, it's going to be a negative I3. Yeah. So I3 is going that way across the 9.0. I'm going that way across the 9.0. So I get a negative IO. Now let's look at the upper loop. Okay, the upper loop, if I just start going up and then I go across the 5 ohm resistor in the direction of I2, so that'll give me a negative I2R 5.0. Now, what do you think happens at the 9 ohm resistor? If I'm just going around that loop, I'm just going around and around and around that loop. It's going to be positive because you notice when I go up across the 5, down, back across, now I'm going opposite the direction of I3. And that equals 0. Okay, so let's go ahead and put some numbers in and collect our 3 equations that we can use to solve this. So equation 1, I1 equals I2 plus I3. Okay, so my EMF is 6 volts, so we're going to do the bottom loop now. So that's going to be 6.0. So I'm leaving units off for the time being. So 6.0 minus, let's see, so the 4 ohm, that's going to be 4.0 I1. And then minus 9.0 I3, that equals 0. And then my other loop, that is going to be a negative 5 I2 plus 9 I3 equals 0. So these are the 3 equations I can use to find I1, I2, I3. Okay. So real quick, I'm going to take that third one and I'm going to move the 5.0 to the other side. So I'll have 5 I2 equals 9 I3. I2 I'm going to divide through is going to be 1.8 I3. So let's take the first equation there. I1, I2 plus I3. That's going to be 1.8 I3. This is now going to give me, so I1 is 2.8 I3. So then I'm going to take my bottom loop, and I'm going to say, well, if I move those I1 and I3 to the other side, I'll get 4 I1 plus 9 I3 equals 6.0. I'm going to go ahead and put, so I have 4.0 times 2.8 I3 plus 9.0 I3 equals 6.0. Once I multiply it, so what, this will give me 4.0 times 2.8 is 11.2 plus 9, 20.2 I3 equals 6. Divide through. I3 equals 0.297 amps. Yeah, so 4 times 2.8, that gives you 11.2 plus 9. So now we have one of them. Okay, well, now I go back up, I say my I2 equals 1.8, I3 equals 1.8, 0.297 amps. I2 is going to equal 0.535 amps. Yep. And so now I1 equals I2 plus I3. That's going to be 0.535 plus 0.297. 0.832 amps. Could I what? Mm-hmm. I did right here. Yeah. Yeah. So this is the order. This is the order that I did it in. The thing about a set of linear equations is you can solve them in any number of ways. This is how I did it. You have 3 equations, 3 unknowns. You're going to have to use these equations in different ways to figure out the unknowns. Okay, so I'm going to give you. Nope, you can get it from someone else. So I'm going to give you a circuit, and you're going to solve it. There's a battery there. We're going to add a second battery to this. Here's the top loop. There's the bottom loop. So I'll give you some numbers now. Okay, so we have plus terminals, negative terminals. Let's see, you're gonna have 4 ohms. You're gonna have 6 ohms. You're gonna have 2 ohms, and then you're gonna have 10 volts, 14 volts, and then you will have I3, I2, I1. So now you're gonna have to choose your loops. You're gonna choose which way to travel around those loops. And you're going to work on this in groups for a little bit to try to solve this using Kirchhoff's rule. You define I1, I2, and I3. I would suggest using a bottom loop and a top loop. I've seen people before use the entire thing as a loop. That works, but it can get a little confusing. No. The bottom loop would be on the bottom. Again, it doesn't matter which way you go. No matter, you choose your way and it's going to assign the positives and negatives. Yes. It gets the same answer no matter how you travel because the positives and negatives will switch based off your direction of travel.
Why is the before only in the
What? Really? The top loop on the other one only has a few resistors, so it's total adult heat. So like look here, your bottom loop, you have resistor, battery, resistor for a total delta loop. Your top loop, you have resistor, battery for a total delta loop.
I see. Yeah.
You do what? Yeah, yeah. It's a little one. Don't worry, supposedly tomorrow they'll all be fixed.
We have a snow day.
Well, someone, not unless the school says so, and if you get a day off, I wouldn't cheer too hard because you're gonna get, lecture videos put up, and usually I make the lecture videos on top of longer than the class.
That's fine, though.
Well, tomorrow's the lab day, we'd have to figure something out. The group, so remember, morning lab is not leaving tomorrow, afternoon lab is, because the morning lab's already done the lab. Afternoon lab has not done the lab. Now, if they cancel classes tomorrow, we will still, the afternoon will still do the lab, it's going to do it on the. I don't think so either. They don't usually do it for snow. They usually do it for dangerous cold.
Like that
So-
time last year.
Yes. Yeah, it got down to like -20. So if it gets down, like if it gets down to like -10 or below, they'll probably cancel. Usually not. Oh, no.
Oh, you're going this way. Where's it supposed to get? Oh, God. It's a lot.
Yeah, well, that was a couple years ago, like that was like feet of snow.
Yeah, freshman year, like, I think that the day before, my break was over because I heard the horrible snow. Horrible. Well, that's just.
Oh, yeah.
I was like, yeah, get that hurt me.
Well, someone said we're supposed to get several inches of snow tomorrow, but not anywhere near feet. Yeah, but isn't it supposed to, it's supposed to drop down to -1 anyway, so I don't know what the wind chill will be after that. If they do, the afternoon lab's just gonna have to do the lab on their own. Cause I went to the dean, got it set up this way so that we could try to keep things fair. So that, cause again, oh, what was that? Yeah, the Wi-Fi went out. So there were a number of options. It's like I was either going to tell afternoon lab to do it on their, like, well, I mean, if they cancel again, if they cancel, then you will have to do it on your own, but like afternoon lab is gonna have to do it afterwards. Which means they wouldn't have got to do it in lab with help.
Six, 7 inches.
I don't get it. You cannot meet somebody that has no meaning in sense. Just know every time you do that, Aristotle will punch you in the face. The what? Yeah, so, well, like, look at the. Well, I guess I can't really tell you, but almost really sure to travel around the. You have hot levels? Okay, so in there, that would be a negative 4 out of 6. Yeah. Yeah.
No.
On the top of the floor, because you're going, in the opposite direction by 1.
Yes. I see.
Your batteries can both be negative, you see that?
Yeah, because they both go.
No, positive, negative.
So, like my bottom was, like, going like this.
Yes. Yep.
So then my top is still going this way, but going up here.
Yeah, your top would be going like full.
Oh, my top's going like that. Oh, now, okay, now I know that makes sense.
So some people latch on to Kirchhoff's rules really well because they're, you know, they are good at like seeing how to solve these equations. I don't know if we'll get it today, but the other way you solve these might be better for some others of you, because if you can just remember certain theorems and put them in the right order, then you can plug the number. So that's the other way to do it. In the past, a lot of people have not liked the second way because you're working with equivalent capacitors and equivalent resistors. You have to condense everything down into a single capacitor or resistor, And then you have to then space it back out based off what you have calculated. You have to remember certain things like the pouch series and series all have the same charge. Everything in parallel all has the same double D. So the other way to do this is remembering those things.
Oh.
Then back up here. You know, I see all the here, you know, I want to go. No, you can't stop here. You know, yeah. And now you're gonna look on you're gonna get down to my three can go around the bottom across the field. You can go on anything where you can do. And if you can come out, not to that. Right. If I come here, that all. Then you ready to pick one of the smaller. So your first equation, did anyone notice that it goes like this? Because I3 comes around. It hits the junction, splits into I1 and I2. I2 goes around I1 with a cross, we reform at the other junction. And back into I2. Oh, it's like. Yeah. You have to look at the two currents that are going to eventually meet equal the other currents. You can't have I2 with I1, I3 because I1 can go that way, I3 can go this way. By the time I3 is here, I1's over here, they don't meet. So you're looking at your junctions. So like I3 is going to come all the way around here, it's going to split into I1 and I2. But you know that I1 plus I2 has to equal I3. Let's look at another combination. If I come around, let's say I say, well, what one into I2 equal I1 plus I3. Okay, well, let's look at that. I1 is going to go that way. I3 is going to come around. I3 is going to be here, while I1 is over here. They don't meet at a single junction. Again, it depends on how you go around the circuit and which loop you go. Well, we'll have to finish solving this next time, but I'm gonna show you the two loops that I made. I did those. Yeah, it's the entire thing. I'm just moving in that direction. It goes battery, so it goes battery to 6 ohm resistor to battery to 4 ohm resistor back to the original battery. Yeah, so because you're just going around that loop over and over and over again. Let's look here. No, it doesn't matter which way you go. So here, the bottom loop, and I just called these battery 1, battery 2. So we're going to have the delta V. So bottom loop, delta V of battery 1 plus the delta V of the 6 ohm resistor plus the delta V of the 2 ohm resistor equals 0. Now, the way I'm going, you see how in that loop I go negative to positive on the battery? That's 10 volts, positive 10 volts. I go across the 6 ohm resistor in the same direction as I1 minus 6.0 I1. I go down and around, I go across the 2 ohm resistor in the same direction as I3. So minus 2I3. So there's that one. Okay, we're out of time. Keep working on this. We'll finish solving this next time. I'm going to go ahead and draw in some figures so we can move a little faster. Yeah.